Hey, polar bears and polar cubs, it's our last section of notes. So let's get a little excited. What we're going to talk about today is titration. So, what a titration is when you have a known molar concentration of a solution and you want to determine the molar concentration of an unknown. We do this through stoichiometry. You can call it acid stoich, but really it's just solution stoich with a possible additional step. Okay, and the big thing that we have to talk about is an equivalency point. An equivalency point is when the hydronium ions, which are really just a water ion or a water molecule that's added an additional hydrogen ion, are equal to the hydroxide ions. In other words, we can just say H pluses equal OH minuses. So this is where we would get a pH of 7. Okay, and right here on the left is a little picture of kind of the titrations and how they're done. They're used with a burette. You put a known base into that. You can have a little bit of an acid in a beaker or an Erlenmeyer flask, and then you put a couple drops of an indicator in there. And then as you slowly titrate the base into it, you're going to see this like pink color or red color, depending on what color your indicator is, appear. And you can stop the burette at any point and then keep swirling. And if it fades away, you haven't reached your equivalency point yet. It's when it's the most faint, the faintest of the color that the indicator turns, that you have reached the equivalency point and you want to stop. So let's go ahead and talk titration math. So in order to do acid stoichiometry, which is titration math, you're going to need a balanced chemical equation. You're going to need to know your givens with the units, and then your unknown with what unit you'd like to give. And we're always going to start with given over 1. We have to pause with our mole ratio based off our balanced chemical equation. And then here's where we have a little bit of a conundrum, you might say. So if you don't have the molarity of the compound that you are ultimately solving for, you're going to stop at the mole ratio. But if you do know the molarity, you can use that to then determine volume. So if you stop at the mole ratio, then you're going to have to use the molarity equation to get your final answer. So let's go ahead and try a couple together. So the first one that we want to use is we have, when determining the concentration of 10.0 milliliters of HCl, a chemist titrates 20 milliliters of 5.0 times 10 to the negative third molar NaOH. So we're going to start out with our given. So like first we need our balanced chemical equation. You have HCl plus NaOH. This is going to give us NaCl plus water. It's completely balanced. What I like to do is I like to know, hey, I have 10.0 milliliters here. I have 20.0 milliliters here. And I also have a 5.0 times 10 to the negative third molarity. So this is going to be my starting compound, and I'm going to then go to HCl. So we'll start with 20.0 milliliters of NaOH. The reason I'm starting with the milliliters here is I'm going to just build in the conversion factor of 1 liter per 10 to the third milliliters. I'm just going to put it into my stoich work. That way I don't have to move the decimal place, which is quite easy, 3 places to the front. Now I'm going to use the 5.0 1.0 times 10 to the negative third mole per 1 liter. This is of NaOH. Per my rules, since I don't have the molarity of the compound I'm going to stop at the mole ratio. So I can only go to the mole ratio of mole HCl over mole NaOH, which is a 1/1. When I solve for that, I get a nice round answer of 1.0 times 10 to the negative fourth mole HCl. Well, if I have the moles, in order to find the molarity, which is what they asked us to find, we're going to use the equation of molarity equals moles over volume. Remember, volume has to be in liters. So we're going to move this decimal 3 places to the front. And on the bottom, I'm going to get 0.010. And up top, I'll get 1.0 times 10 to the negative fourth. Sig figs are going to be based off of my givens. As you might see, my 5.0 only has 2. So my final answer can only have 2, giving me a final answer of 0.010 mole per liter HCl. That is a very low concentration of HCl. All right. Now, let's go ahead and check out another example. Again, let's bounce up that chemical equation. You have HCl plus barium hydroxide goes to barium chloride plus water. In here, we're going to have to balance it up. So I put a 2 here, which then produces 2 waters. So it says Mr. Day I used 27.4 milliliters. So I'm going to put that in liters just automatically. 0.0274 liters of a 0.0154 molar concentration. And I'm going to have to move those ones over because those are actually associated with, oops. Those are associated with barium hydroxide. With HCl is the 0.0200 liters. So this is set up very similar to the previous one. So go ahead and try to figure out the molar concentration of HCl, and you'll be able to see the work and the answers here in 5, 4, 3, 2, 1. So we're going to go ahead and start out with 0.0274 liters of barium hydroxide. And we're going to multiply that by 0.0154 molar or moles of barium hydroxide over 1 liter barium hydroxide. Again, since there was no molarity given to me of my second formula, I'm going to stop at the mole ratio. So this is going to be moles of HCl over moles of barium hydroxide. That gives me 1 and 2, giving me a final mole answer of 8.439 times 10 to the negative fourth. And this is moles of HCl. So just like before, now it is time to then use molarity, mole over volume. So we're going to take that 8.439 times 10 to the negative fourth over 0.0200. And sig figs based off of our givens, all three of them had 3. So that would give us 0.0422 mole per liter HCl. Slightly more concentrated than the previous one, but still nowhere near where concentrations might become irritants towards your skins. All right, I'm going to have you guys do the third one completely on your own. I will bounce chemical equation for you, and then you guys can work through it. So we have strontium hydroxide plus HCl goes to strontium chloride plus water. All right. 3, 2, 1. So with this one, we know the volume and concentration of the acid. It is 0.04303 liters. It is also a 0.01159 molar solution of HCl. And we were given the molar concentration of strontium hydroxide. So on this example, you would be able to just stay in stoich and go completely from one reactant to the other for volume. So we're going to start out with the 0.04303 liters of HCl over 1. We're going to multiply that by its molarity, which is really just moles over liters. And this is, again, of HCl. Then we're going to multiply by our molar ratio. We're going to go to strontium hydroxide from HCl. So a 2 on the bottom, a 1 up top. And finally, since they gave us the molar concentration, we can use that to put 1 liter of strontium hydroxide over 0.0325 mole strontium hydroxide. Okay. So notice how one molarity, the moles are up top, the other molarity, the moles are on the bottom. This is going to give us a final answer. You can multiply all the tops, divide by 2, and then divide by 0.0325. And that's going to give us a volume of 7.67 times 10 to the negative third liters strontium hydroxide. Now, if I were to move this to milliliters, what would really happen is I'm going to multiply by 1,000. That gets rid of the 10 times 10 to the third, or you could say that it would only take 7.67 milliliters of strontium hydroxide to neutralize the 43.03 milliliters of hydrochloric acid. All right, that has been kind of titration math or acid stoich. It has been my pleasure having you in my classroom this year. Good luck on the worksheet.